what's world's biggest taxi company? Uber. So how many cars does Uber own?
Not one single car.
Right. So what's world's largest accommodation company? How many real estate, like how many buildings, flats does it own? Nothing, right? Then let's go to world's largest retailer. It's debatable, but it's probably Alibaba. So how much inventory do they carry? It's again near to zero. And then we are talking about world's biggest social media company, Facebook. How much content in Facebook does Facebook own? Again, near to zero. So what we are talking about here is they do not have their own data. The data is coming either from the vendor or from the customer. The person who is buying it or the person who is selling it. Now, if we take these examples, what we are dealing with here is enormous amount of data. And on top of that, you use your algorithms, your machine learning algorithms, which help you, which is basically the mathematics of finding trends and patterns, right? So using that, you find out whenever you log into Amazon, you create an account with Amazon. Next time you log in, it will suggest you that these are the products that you might be interested in. How does it know that? Because it has already put you in a bracket within a group, with other customers, right? So they know that what are the other members that are there in your group have bought, and what you have bought, they haven't bought. What they have bought, you haven't bought. So you get your recommendations based on that. It's nothing but the volume of data that matters here. Not only the volume of data, how you store the data, how you get the meaning out of that data. That is what is important. Now, let's talk about, this thing is often said, data is the new oil, data is the natural resource. So if we talk about oil and gas, if you take a standard facility where you have around 80,000 sensors, it generates around 50 terabytes of data. 15 terabytes of data. Public safety, if you take New York City's traffic cameras, every day it will capture around 520 terabytes of data. We are not even reaching to a point where we can analyze the data. First, we need to think of storing this data. First you store, then you start analyzing, right? You cannot just put it in hard disk and keep it somewhere else and think of analyzing it. That will never happen. Then energy and utilities, 680 plus million smart meters, which produced 280 petabytes of data only in 2017, and the number is increasing. Healthcare, the equivalent of 300 million books of health related data is produced per human being in his lifetime. So you can understand 300 million books, average size of books defined. So this is all debatable. But the point is, the amount of data that we are talking about is huge. So data is everywhere, and that's a good thing. Now, we are talking about the data that we have been working on these 10, 15 years where this business analytics whole thing has formed. We had been mainly working on structured data. Structured data means which we can put into an Excel sheet, which we can put into a table and start working on top of that. We can apply various types of database rules on top of that. We can use data warehousing, we can use business intelligence. But what we are seeing now is the data that is coming from social media, the data that is coming from sensors, the data that is coming from IoT devices is not structured, it's unstructured. It's textual data. Not only textual, it's qualitative data. You cannot assign a quantity into it, right? If you cannot put a quantity, you will have to analyze the data first and then assign the quantity, right? So that's how you convert the unstructured data into structured data. So that's your first project. After that, you store the data and start applying your different types of algorithms and techniques. Now, let's talk about some data analytics challenges which you may see. These are just some samples. Probably turn 12 terabytes of tweets created each day into improved product sentiment analytics, product sentiment analysis. So instead of that, let's think of a situation where a celebrity has tweeted something. Within 30 seconds, you get around 10,000 retweets. You are trying to find out where is this celebrity's fan base, and are they talking positive about him? Are they talking negative about him? Are they neutral about him in their opinion? Or is it a false positive or is it a false negative? So you have no choice but to dump this data somewhere, then starting to analyze, right? Then another example, converting 350 billion annual meter readings, which comes out of smart meters, and predict better power consumption. Again, first you'll have to store the data, mine the data, come with some predictive algorithm, and then predict it. Scrutinize 5 million trade events created each day to identify potential fraud. So again, the same thing. So that's why the portion of big data here is, if you are talking about how the industry will shape 10 years later, it's very hard to predict. But whereas the trend goes, if you read the Gartner hype cycle for emerging technologies, 2005, big data was on top. Now big data has vanished. Now what we are talking about in that loop is self-service intelligence tools and machine learning. So machine learning is going to be a huge part, and you can say that that's where we talk about this corpus, right? We collect data and lay a foundation, and you can learn from data and solve problems. That's what cognitive is. And going forward, there is no other way. You call it cognitive, you call it artificial intelligence, it's the same ball game. But the point here is, unless you understand these basic principles, that's why we talk about a lot of retraining in the industry going on right now, right? Where people are adopting the newer technologies, which are per se the data analytics with a focus on artificial intelligence, machine learning, etc. So, and as per the predictions go by some all over the world, they say by 2020 you will see around 28% growth in this industry alone, in terms of data scientists who will either work on advanced analytics or work on the cognitive section of it. Any other questions?
What IBM Watson source?
No, the point here is not about we were just trying to define what is a search engine and what is a cognitive engine. So one is, the corpus is so big that it will mine the whole data set all over the world, and it is based on keyword. So you will find relevant results if you write not plus elephant in Google, because then it understands that you are talking about this. But why do I change that? I should be able to communicate to a cognitive system with something called NLP, like natural language processing, right? Where what happens is whatever you say gets translated into a business question in the mind of the tool, and it will give you an answer. So the point here is, the cognitive analytics that we are talking about, it depends on the corpus that you have created and how you have fine-tuned the system. And that's how you define your chatbots these days, right? Where you train them specifically on a particular question. This question, this answer, but this question might have hundreds of varieties. So you train the tool on those 100 questions. Any other questions?
NLP or cognitive sciences?
Cognitive sciences, I'll say that we have something called IBM Watson, which has multiple pieces actually. It doesn't say that Watson has products which are basically, you can say, a fusion of multiple APIs. What are APIs? APIs are various nuances of artificial intelligence. If you talk about visual recognition, if you talk about text-to-speech, speech-to-text, if you talk about chatbots, which is nothing but NLP, and then if you talk about discovery, these are all fragments of AI, right? Now, if you sum two of these up and solve a business problem, then you define a tool with Watson. That's what we do. That's why you see a lot of tools coming out specifically for some industry. It will solve a particular problem, but it's nothing but more than some of these APIs, and it's one of the most used tools today. Any other question?
Yeah, suppose I'm recruited tomorrow as a data scientist or a data science person in an organization. What do you define as my basic qualification?
That thing differs a lot from company to company. I go by DJ Patil's definition of data scientist. Data scientist can be anybody, right? Who can, general definition that we followed in the industry is data scientist is a person who knows a little bit of mathematics more than his peers, who is an engineer who knows more mathematics than his peers, and who is an, you can say, computer programmer who knows a little bit, like, it will be two things actually. One is you will know computer science, you will know mathematics. Mathematics means your trends and patterns which you will apply in machine learning. So these two things will go hand in hand. But along with that, domain knowledge is also given a lot of value, which you do not learn on the first day and which has a steep learning curve as well. But the point is, I have seen people getting into data scientist roles who are coming from computer science background, who are coming from economics backgrounds, because in case of economics, you do a lot of financial modeling, which actually helps in this case. And also, like, there are a set of tools that you need to have mastery on, and there is no end to it, believe me. With the open source umbrella, not only one company's tools, it will be more than, obviously, you learn a set of tools. Along with that, you augment it with R and Python. And you need to learn a platform where data scientists can run their projects. So that is mostly it. Any other question? I think we are done.
Thank you, Mr. Rajeev. Now we are going to have a young speaker. He's an alumni of SSN. Now he's currently working at Fractal as data scientist. Can we have Prakash on stage, please?
So hi everyone. So it's been a quite informative and cool session so far. So it's almost 12:30, so you'll be very hungry, I know. But let me not consume much of your time. So I'll take some 10 to 15 minutes. So I'll try to walk you through what data science is all about. What are the skill sets required? I think that's your question, I guess. So I'll try to answer that. So what are the skill sets required, and how does SSN's PGCBA will help you achieve your dream of becoming a data science professional? So this is what we are going to discuss for at least next 10 to 15 minutes. So data is the new oil. So superstar of Indian business, Mukesh Ambani. Sexiest job of 21st century. I think this is the statement that has revolutionized this data science world itself. So Harvard Business Review. So then best job of the year 2016, Glassdoor Review. So now everyone speaks about data science, big data. Like, do you people believe all these hypes worth? Maybe after you have heard the sessions from 4 experienced speakers. So what do you think? Are these hypes worth, or it's just people have exaggerated? So no one has the answer. At least partially worth. Okay. So what is data science? Any guesses? Let's keep it interactive. Let's not a normal lecture kind of session. Sorry? Survey. Okay. Any guesses? Getting insights. Okay.
So the worthiness of data science, who's your current billionaire of the world?
Sorry?
Billionaire of the world.
Okay. Okay. So.
It's not Gates anymore.
Okay.
The competitors are people who are used to data science.
Oh, it's an unexpected answer. Okay. So I'll try to put up in a simple and precise manner. So you have a huge volume of data since we are moving into a digital era. So if you just take your mobile phone, you can see, take any app like WhatsApp, Facebook, Google Maps, Paytm, whatever it is. Everything is data, and all the data are being monitored and recorded and kept in their database. So it's like, it's not completely fault if I say your each moment is being monitored. So each and every app has data. So since we are moving into the digitalized era, the volume of data are becoming huge. So if the data is just data, it's of like no use for the people, like for any business. So you want to beat the data, use any tools or statistics, and try to make sense out of the data. And using that insights, the insight should not be just insights. Like Mr. CJ told, the insight should be relevant. Like it should be an actionable insight, to be technically called. So it should be an actionable insight. You have data, you can read the data, you get the actionable insight, you suggest the decision maker to go ahead with its result. So that's what data science as an overview. So this is a statement by chief economist at Google. So this will help you identify, like quantify the volume increase in the data. Between the dawn of civilization and 2003, we only created 5 exabytes. Now we are creating that amount in every 2 days. By 2020, the data size predicted to be 53 zettabytes, that is 53 trillion GBs, a 50 times increase. At least you will understand at what pace the quantity of data is increased. So this is the technical definition. Extraction of insights from large volumes of structured and unstructured data is called data science. So what is structured and unstructured data? Structured data.
That can be put into rows and columns.
Yeah, normal rows and columns, traditional RDBMS. So unstructured? Voice, video, text, all those things. So we understood what data science or data analytics is. So who is a data scientist? Sorry? So to answer this question, we want to understand what are the skill sets required to become a data scientist. So these are the skill sets required. So one is programming, statistics, visualization, database, domain, communication skills, storytelling, big data. It's kind of huge list, right? So what happens is you have data, it is stored in, let's consider to be a normal RDBMS. So you have data, it is stored in the database. So you should be good in database technologies to extract data out of that. Only then you can make sense out of it. So for that, you should be good in database technologies. Then comes your programming and statistics and visualization. So programming, as of now, the hard tools are R and Python in the market. So you use R and Python to implement the statistics and visualization to get information out of the data. So you use database technologies to get the data. You use programming, statistics, visualization to get sense out of the data. And then now you have analyzed the data, you have the insights. What if you couldn't communicate in a proper way to a decision maker? So those people could not able to understand the statistics. So you want to convey in them in a manner they can understand. So you should be good in communication skills. Else the efforts, all the toil and moil you have done will be of no use. So you should be good in communication skills as well, storytelling and big data. So big data, since the volume, it's kind of huge, you want a platform to process those data. So for that you use big data, top of which you can use R, Python, a lot of technologies are there. In big data, if you say Hadoop, Spark, Flink, it's been a quite rapid pace for big data technologies. So these are the skill sets offered at SSN PGCBA. So in programming, you will be learning R, Python, or Java. So you will be learning at least 2 programming languages there. Then statistics. So statistics, there are different types of statistics: descriptive, inferential, predictive. So basically, you will be using statistics to make sense out of the numbers. If you just stare at the data, it will be millions of rows and thousands of columns. You won't understand anything. So only if you apply the statistics over it or visualization over it, you will understand something. So just imagine there are 2 columns. One is gender and the other one is number of quantities of product being bought. Okay. So there are some millions of rows. Will you be able to understand anything? But if I show with us 2 bar graphs, one is male and one is female, 70%, 30%. Will you be trying to get some insight out of it? So that's the power of data science. It's a way. So then Tableau, it's one of the as Gartner report says, it is one of the leading visualization tools in these days. So if you could go across any job requirements in Naukri or Facebook or LinkedIn, so you can really see this Tableaus of one of the biggest use. So then domain comes. Domain plays a bigger role because you should be clear in the domain jargons. If I'm working with a financial or banking domain, I should be good in the banking jargons. Otherwise, I couldn't make really sense out of the data. So I can say that this is correlated, but what if they are not? So only the domain knowledge helps in enhancing the process of making insights out of it. So domain knowledge is kind of must. So you will be having sessions from experts in domain like retail, financial, a lot of domains. So and obviously communication, how to present, like PPT making skills, how you want to present yourself, and how to approach the job opportunity, how to present yourselves. Those are the extra additional skills you'll be learning there. And then in big data, you'll be learning Hadoop, most probably MapReduce, MapReduce, big Hive, those kind of things you'll be learning. So you understood what data science is all about, who is a data scientist, what are the skill sets required to become a data scientist. So what are the day-to-day activities of a data scientist? So it starts from data collection. Data munging is nothing but data cleaning. So I won't say that you'll be getting an opportunity to work in all these areas, but it depends on the company and the size of the team you're working. So in my previous organization, I got the team was almost 4 to 5 members. So I got an opportunity to work in all these areas. From the data collection, data from multiple sources you want to collect, you want to clean it, you want to prepare the data to make the analysis over it. So that is your place where you start your analysis, data science work. Then comes to the doing statistical analysis, and predictive modeling is my favorite area. So it depends, it changes from person to person. So building models and reporting the insights. Basically, you use Tableau or some visualization tools to report the insights. So some people can get opportunity to work only in data collection, only in data mining. So it depends. So some can become a visualization expert. No, it depends. It varies from organization to organization.
Thank you, Ram. Now you can know a lot about SSN School of Advanced Care Education in the form of AV.
The hallmarks of a successful educational institution is its ability to meet the demands by creating industry-ready professionals. Dr. Shiv Nada, Chairman, HCL Technologies Limited, is a pioneer in the field of information technology and a visionary entrepreneur. Having recognized the need to bridge the gap between academia and industry, Dr. Shiv Nada established the SSN School.
That is SSN. So now you are open to ask any questions regard to this program or whatever you had in the previous sessions. So our speakers are here to address your queries.
I would like to call Professor Jay Karthikeyan, Dr. Arvindan, Dr. Shivakumar, and Sundar, and Vinod Chandar and Priya Vinu. Yeah, these are all, okay, all of us consist of the team members, and plus, as we had already said, we have a host of industry practitioners, like what you saw today. Like we not only give the academic flavor, but also it is mixed with how to apply the academic knowledge in the industry environment. That is why we invite a host of speakers from industry. Now we have realized what you saw in the video was the full-time 6 months full-time course on whereby it was meant for accelerated learning, because a few people we realized that they give up their job and then join the program as a full-time person or a learner, and they want to start earning at the earliest. Now at the same time we got lot of queries from practicing professionals who, without giving up their job or the current practice, they would like to enhance their knowledge. So what we have done is to modularize that. That is, we have divided the whole program. Number one, you learn at your own pace. For example, say you join us today, and after 4 months you may be depicted or you may be deputed on another project which may not be in Chennai. So what we have done is to modularize the whole program into 3 distinct modules. The first is to enable you to enter into data business analytics field, that is by wherein we cover data engineering, visualization and simple statistical techniques and all that. And then the second part is the entry into data science in detail, like predictive modeling and other things, which again run for 4 months period. And the last but not the least is the advanced data science, where if you want to master the techniques like what you heard right from morning from Sameer or say Rajeev or even CJ sir, all those are covered in the advanced techniques. Now parallelly what you